Hello folks, welcome to the stream. How's everybody doing? Welcome, Rockstar 2.0, the inventing the world's stupidest programming language again, because why would we not do that? We were on, I don't think I was on yesterday, but over the weekend, plugged in a bunch of things and sort of got to the point where I had a sort of reasonable, what I felt to me like a reasonable approach with a tokenizer and a scanner and an interpreter and something that actually ran and could do basic arithmetic expressions with order of precedence and everything. And we have hit we've hit one of those it depends kind of situations, because I got to the point of having to start thinking about equality, and by which I mean comparing two things in programming and deciding if they are in fact the same. And this is where things get genuinely... Hello, Rob. You did not miss very much. You missed about 3 minutes of me going hello and welcome to the stream. So here is the headache. In a nutshell, let me open up a VS Code window here, so I'm not trying to use Visual Studio as a notepad because it's a little overpowered for that. In Rockstar, there is we have keywords with spaces in them. So something like, let's say we've got some expression x, and we want to do if x is greater than y. Okay. Now in Rockstar, this would be if x is greater than y, because it's a very, very verbose language, because it's based on lyrics, based on song lyrics and stuff. But also, we could have a variable called z. So we can say if x is z. Now, the difficulty here is that the scanner that is going to take each of these lines and turn it into a series of tokens that then gets fed into the parser to generate the syntax tree. This is going to look at this thing. Give me one sec. Hang on. Oh. This is going to look at this. Now, I understand. I'm not an expert on this, but I have read most of the book. I do actually have a degree in this stuff. I'm a qualified scientist, but that was a long time ago. So generally what we wanted to do is look at this, and in this instance, it's like, okay, we'll find a space. Okay, that means there's a token. Look at the token. What's the token? One of those. Okay, find the next space. The space means that's the end of the token. The space means, we're now doing something different. But this here is greater than. What we've got there is we've got a token with spaces in it. And so the tokenizer is going to look at is, and then a space. And then it needs to go, all right, well, hang on. Where am I? Am I at the beginning of a multi-part keyword here, like a multi-part alias or identifier? Or is this something? So what I need to do is, at this point, we look at is space z space. So there's another space on the end. So if we get to is z space, at that point, we know that z is not part of any keyword we recognize. So we need to give back is. That's the token we need to match. And is here, hey Jake, welcome back. That is there corresponds to equality. That's the, we are looking at two things here to see if they're equal. But if we start tokenizing and we get greater than, now, this of course raises the sort of slightly interesting question of, could we in Rockstar have a variable called greater? Could we say let greater equals 5, and then we could have a if x is greater, because in theory, like, that should allow that to happen. And I don't actually think, I think this will just fall out by mistake. I think this will actually be possible, because what it'll do is it'll say if x is something, if x is greater than something. So what I'm going to do here is we're going to spin this up in isolation. if we have a look at the way the scanner here is implemented, so we got the scanner, crank that up a little bit. Let me move some of this stuff just out of the way, just a little, so you can see what we got there. And so this is the fun part here, is I'm about to add another thing to this, which is the is keyword. But you can't see my screen. Let me, yeah, there you go. I'm going to switch off studio mode. Thank you. Yeah, that's... every once in a while, I do these things on stream, and it reminds me how utterly miserable I got having to do everything on the internet during the COVID lockdowns, where you would be running, workshops and running conference talks and all that kind of stuff, and you'd miss some tiny insignificant detail, like the fact that you'd forgotten to switch the screens over, and you'd realize after 20 minutes, and then you'd be like, there's been supposedly 18 people watching this for the last 20 minutes. Why did none of them say anything? Are they there? Are they dead? Do they just not give a crap? Are they only doing this because their boss told them there was training today? Yes, thank you. It is astonishingly easy. So the whole, doing these kind of streams is... it's like trying to fly an aeroplane while you do a comedy show, except the people watching the show aren't allowed to realize you're flying the aeroplane. And so you're trying to keep the plane flying straight and level and not worry everything while giving the audience your undivided attention. And, yeah. And yeah, lots of folks, because often it's something between... Rob has me on their phone while they work. Hello world from Rob's phone. Anyway... Right, okay, good, you can see my screen. So what I did there, in case anyone really cares, is I'd switched on studio mode in OBS, which means that when I hit the little buttons here on my magical dashboard for switching scenes, it doesn't actually switch them. It just goes, oh, well, this is what would happen if you pushed that other button there. So, right. So just a quick recap. The problem we've got is we need to be able to ambiguate between... Is ambiguate a word? Yeah, we need to be able to ambiguate. Disambiguate. That's what we need to do. Between this and between that. And so what I'm going to do, the first approach I thought I'd try here is I got this dictionary of keywords here, right? And what I'm going to do with this is I'm going to add elements to this dictionary. So I got an extension method here called match, which returns a token type. So let me spin up a little test here, because I'm gonna build this kind of on its own in isolation in a unit test, so we can see if it's going to work. So let me just come down here. Now I am going to ignore those tests, and I'm basically going to get a bunch of noise out of the way, and I'm going to ignore those tests, and I'm going to ignore those tests. That should have disappeared. Show ignored tests, switch that off. Yes, there we go. Yeah, I do not want to see tests which I have ignored. I want to see tests which are failing. And that should... okay, come on, Crunch, you can do this. Alright, we'll collapse that. We'll ignore the fixture tests. Those are fine. Okay, that thing we can come back to. That doesn't matter. So, what are we looking at here? I'm looking at... let's jump in here and public class keyword tests. Let's split that out into its own keyword test.cs. Alright, so then in under here, that already contains a definition. It shouldn't. Okay, I already have keyword tests. That's alright. We can fix this somewhere else. Get rid of that. Delete that. Actually, let's grab that and move that to keyword tests.cs. There we go. There's that. There's that. Shrink that down just a little. So we've got what's the status update for the interpreter? We have got to the point of I have keywords with spaces in them, which you cannot parse without doing some greedy look ahead. So I'm figuring out a nice way of doing that in the way the parser works. So I'm gonna create a okay, so we've got scanner.keywords, that's working. All right, so let's say public void keyword matcher is greedy. All right, so this is what we want to get working. So let's say var keywords is going to be a new dictionary. It's a dictionary of token type, and array of string is the structure that I've used for this. And this is going to include, so let's have a token type dot equal sign, and this is going to match only the keyword is. But then we've also got a token type dot greater than, and this is going to match is greater than. The reason I'm pausing here, previously when the last time I built one of these interpreters, I used a parsing expression grammar for it, and that actually turned out to be a significantly nicer way of dealing with this kind of edge case than doing it with a scanner and a parser. I'm going to plug away with this for a little bit, but it's entirely possible today is the day that we decide I'm not going to use a tokenizing parser for this. I'm going to do it with an expression grammar instead. So what do I got here? I've got so keywords dot match is dot should be token type dot. Now what I was thinking we can do here is yeah. All right, so the test cases we've actually got are we need to keep doing a look ahead, and we keep doing a look ahead, and scanner.cs. All right. So this thing, while peak.is alphanumeric returns next. And so I'm wondering if there's a way I can do this where if you ask it to match a keyword test, so that should return two different things, because this consuming the token is means we are looking at either an is or an is greater than. So consuming this lexeme here means the next thing on here is going to be it's either going to be an equal sign or it's going to be a greater than. Now the difficulty is, all right, so let's assume that match is going to return more than one token. It's going to return anything. So is should be, and this should then return token type dot equal sign, token type dot greater than. All right, now that's going to complain because it's going to say you can't do that because this thing here is, now why is that complaining? Cannot initialize token type with a collection expression. Yeah, okay, so that's cool. So I need to change the signature on this. So token type match is actually going to return multiple token types. So what that's going to do is it's going to say that dot where dot select pair goes to pair dot key dot to array. So we give it a piece of text, and what it's going to do now is it's going to say where pair dot value dot any, and any one of those keyword starts with that text. Starts with text, and that is going to be string comparison invariant culture ignore case. All right. So keywords.where that default value can come out. I don't know if this is going to work, but it seems like an interesting approach to try. So that's gonna, we give it a chunk of text, and that's gonna say, okay, keywords match is should be okay. Is that working? The solution will currently not build because I've broken some stuff. Let's fix the broken stuff, and then it'll build, and then we can run the test. Yeah, that's fine. Okay, so this one var token types equals that, and then in here we can throw new not implemented exception to get around commenting out all of that lot, which means we can run the test we had in there. Okay, so that test is now working. So that's given us back that. So keywords.match is greater now. Should be, and that should now be token type dot greater than. Yep, okay, so that's good. But that should now be nothing. Okay. Except this still isn't quite going to work because the token we actually need to is greater here is not going to do it. Is greater is we need to consume the than as well, because we need to consume the entire is greater than. All three keywords, we need to consume those so we can drop in or move on to the next part of the language syntax. So do we need to return match types? Yeah. Using look ahead makes the parser a predictive parser, at least when it comes to keywords. Yeah, the difficulty here is that we can no longer just consume everything up to the next space, and then that unambiguously tells us what have we got to so far. Actually need to look ahead at what's after the space and use that to decide if the thing I'm looking at is important or not. And so the difficulty there is how do we know? How do we figure out how much to consume before deciding that this is no longer so I think the matcher here, this keyword matcher thing, needs to return a it can either return that I've found one of these, I found something that might turn out to be one of these, or the lexeme you have definitely does not match anything. because we've got prefix codes. We've got keywords here which are substrings of the first part of other substrings. Okay, so I think let's try this. And okay, so what I'm going to do first of all is let's stage all changes, snapshot before we break everything. Push that lot. And this is all spike code anyway. It'll probably all get thrown away and we'll cherry pick the good bits. Public enum match type complete partial. All right, so we're going to return a match type and a keyword, and that way we can take a look at what we got and be like, all right, well, we've probably found this, but we might also have found some of those. So we've got to say here, okay, so I'm going to throw in another extension method on here. So this is going to be a private, public static match type match, and this is going to take a array of string, and it's going to take a string prefix, and this is going to return a keywords.select, so whatever the prefix is here, so prefix is equal to keyword, so whatever keyword we got, so if that equals one of those, then we are going to return match type.complete. Otherwise, prefix.equals then we return match type.partial, otherwise match type.nomatch. Hang on. Oh, no, right, scrub that. That's bollocks. Doesn't make any sense at all. I mean, nonsense. Right, so what do we got? So we've got... I wish there was some way of saying, I just want to do that everywhere. I don't want to have to explicitly specify that every time we do a string comparison. But, yeah, that's all right. So we are going to say... public static token type. So this isn't going to return a token type anymore. This is now going to return a token type, and let me reinstate that match type. And this could just be a dictionary, right? So that's going to match a string of keywords and a string of text. So then we're going to say for each keyword, we are going to find yep. So keywords.select is going to take a pair, and then the pair dot value. We don't have ambiguous codes for the same token, so we can rely on the fact that each pair is going to give us a... So this is going to turn pair.key and pair.value. Okay, so this should match only one. We have an array of values. We have an array of keywords. And we want to return a match type. Okay, so try this. So public static match type match this string keywords and then string text. So if keywords.any, so if anything in here is an exact complete match for what we've got there, keyword goes to keyword dot equals text string comparison dot invariant culture ignore case, return match type dot complete. If keywords.any keyword dot starts with text, at that point we return match type dot partial, and then we return match type dot none, no match. Okay, so that wants to there. Right, so what we got on here, hey Surly, welcome, how you doing? We are gonna look at our dictionary of candidates. That can probably come out because we don't need it anymore. So this thing here is gonna say, yeah, pretty good. We just got to the bit where Rockstar is weird enough now that the parser textbooks don't help, because I'm trying to parse keywords which have spaces in them, which always makes life entertaining. So, right, what are we looking at? So what I've got is this thing that says, look, I'm going to give you a bunch of potential keyword values, and it's weird now. Yeah, up till now it's just been completely normal. So that should be. It's a must to use a stack and a table in predictive parsing, but I don't think we need the table now. Yeah, I am. So I've hit that point of it's like, there is a solution to this that I know is going to work, because I know a parsing expression grammar handles all this stuff. As much as I am enjoying, it's that whole thing of where do I want to get to by the end of this week, say? Do I want something that works, or do I want something that doesn't work, but I've learned a great deal about why it doesn't work? And so there's this trade-off between, what am I doing here? Am I trying to build something, or am I trying to learn something? And most of the worst code I have ever seen in my entire life has been code that someone tried to build while they were learning. And like, oh yeah, well, we've got this new project we got to do. I know, let's do it in Angular, because we've never done Angular before, and it would be a great way to learn it. And what I'm doing here. So up until now, this exercise has been about learning and about, getting not the thing I'm actually going to deploy, but building a solid reference full of, good examples and working cases that I can refer back to when I build the real one. This is the pilot system. This is the spike. This is one to throw away. However, if we get to a point where I think the thing I am learning is something I'm not going to end up using, at that point, the question is, do we keep working with it, or do I switch back to something I know is going to yield better results? Because I'm actually trying to ship something here. So what do we got? We got my token match is, now do I return a dictionary, or do I return a tuple, or a list of tuples? And I think I got to return a dictionary here, because I think that this thing is going to say, all right, so what do we got? Let's see why that, well, that won't even compile at the moment. So I'm going to say should be new dictionary token type match type, except that's implicit, so we can target type the new. And this should contain a token type dot equal sign and match type dot complete. Oh. Cool. And we'll comment out that those two. Okay, good. So that's failing. Why is it failing? It's failing because yes, that should actually be returning two things, because that is an incomplete match. That is returning a token type dot equal sign and a token type dot greater than. So there's one of those, there's one of those. Do that, look ahead. Okay, so that should now return partial matches. Okay, that should return a single thing which says we haven't found a token yet, but we are still kind of on the road towards one, so keep at it, this will probably be all right. And this one here should be empty. Hang on. I wish there was a way of filtering dictionaries without turning them into an enumerable that you then need to turn back into a dictionary. Because that last line there, that looks kind of like a bit redundant. Like, surely there must be a way of turning a dictionary into key values when the things you've got have already got. I can't do that, can I? Does that work? Maybe? Okay, that appears to work. Interesting. Okay. Cool, you can do that. All right, so that's now bringing back some interesting stuff. So the question is now, how do I use it? And so what we got to do in here is so this is scanning an identifier, and it's calling keywords.match on the lexeme, and we got a bunch of candidates here. So keywords dot match some identifier dot should be empty, and is, I think. Is that building? I've broken it. Okay. So if token types dot, so what is token types here? It's a dictionary. So if that doesn't contain anything, then we found an identifier. Token type dot identifier literal contains nothing, but it will pull the lexeme out of start and current. So that's cool. But then what I need to do is, so we found something. So now we can say if token types dot count equals 1 and token types 0 dot match that's weird. Okay, today I learned that if you do that array index syntax onto a dictionary, you get out the element, the value. I guess you would, because a dictionary is like key value, key value, key value. So yeah, that will actually work. Equals match type dot complete. Return token, and this will be token types dot first dot key. Now, in any other scenario, we got to think about the fact we found something means we need to keep looking. So we probably at this point want to do something like while token types dot count is greater than 1. That means we found multiple matches. So at that point we want to look further ahead. So we can say at this point, if token type dot count is greater than 1 and peek next, which is currently in here, but it's commented out. Yep. So peek next isn't going to work. Peek next isn't going to work because there could be multiple spaces between the tokens. And this is hard. All right, so what's the thing we got to deal with here is that is valid. So one approach here is a preprocessor. One approach would be something that finds any, instance of is, and then any amount of white space, and greater than, and it finds that whole lot there, and replaces that with literally the canonical representation of that thing. So preprocessor plugs the whole thing in. I can't trim the front, Rob, because I don't have the token yet, because I haven't got that far. What I've done is I've looked at this. So I found X, and then I found a space, and then I've started reading alphanumerics, and I've been like, okay, I found IS, I found space, that means this thing's a token, let me look it up. But now what I need to do is peek next, and peek next, if it's alphanumeric, I can trigger in the next round of parsing. But I this whole, like, if consuming white space, I guess I could just keep consuming until I get something which is not white space. So this is the chunk of the main token loop, or the main scanning loop, that says, look, if you find one of those, you return null, like nothing comes back. Those are just white space. And I can possibly modify, what does next here do? Because one possibility, yeah, that's all right. One possibility here is that I just have the next thing, and next will advance to the next thing, which is not whitespace. And so whitespace gets ignored by the way the scanner works. So that, I'm just trying to think, so we can have spaces inside of string literals. Hello, Teja. Hello, anyway. So what does scan string do? Yep. Let me see what happens if I do this. I'm going to move that lot into the next thing. So that's next, because those things don't return anything. So private char next is going to say, where are we? Return source current plus plus. So current plus plus means we're going to return the source. We're going to increment that. So we can say while true switch on that. If it's any of those, continue. If it's that, can I do this? Yeah. Yep. Return C. Bail out of that. My latest YouTube video just went live and people are commenting on it, and reading the comments on YouTube is one of those things that we know we shouldn't do, but we do it anyway. All right, so while current is less than source.length, is that the default value of a character? So I think next should now consume any amount of white space as it goes along. Except peak next needs to do the same thing, doesn't it? Yes, I'm on YouTube twice right now. There's a new video I made earlier, and there's a new video I'm making right now. And if you watch this one, you get to be part of the experience in real time. And the other one is just pre-recorded and will be out there until YouTube eventually succumbs to the heat death of the universe, I guess. So, private char peak is at peak next current, but that's fine. And, right. So what I'm trying to figure out is there a scenario where peak next is going to... Does it make sense for peak next to return the next thing in the stream which is not a whitespace character? Okay, so this thing kind of chunks through it and finds each element, and when we end up pointing at a space, yeah, okay. So current is now pointing at something which is not a lexion. It's not part of the alphanumeric sequence. So token types equals a match. While token types.can is greater than 1 means we found the thing we found matches more than one thing that could happen next. And peak next now potentially needs to look ahead to the next character, which is not a space. I mean, the difficulty we've got is that in Rockstar almost everything is alphanumeric, and so the sort of standard convention of in languages like C, there's a relatively small number of keywords. Almost all of the language is made of non-alphanumeric characters, equals, brackets, braces, less than, greater than, all that kind of stuff. And so when you do find something which is alphanumeric, if it's not one of a small number of keywords, then it's an identifier. It's an identifier which is part of the user's program, not part of the actual programming language itself. Because I have so many keywords here which are alphanumeric and some of which contain spaces, the scan identifier thing here needs to be greedy, and that's the thing which is causing the difficulty here, is we need to consume as much as we can, including arbitrary numbers of spaces and possibly even new lines that are part of the spaces there, and turn that into a single token which matches the whole of the thing that we have consumed. And so we keep scanning ahead. Okay, so we scan alpha, then white space. Hang on. All right, let me think this through. So what are we going to do? So we've got identifier followed by white space. Identifier, round and round and round and round and round. And then look at the last. So we keep going until till we find a complete match. We keep looking ahead until we find a complete match. And when we get to a complete match, we go a little further, because, yeah, are you winning? No, we are very much having fun in games today with how to extend the locks scanner example to handle keywords which have spaces in them, which is proving entertaining. All right. Okay. So we get to this point here. At this point, source start current is an alphanumeric sequence. So now we need to look at the next one. And we can't bail out at this point, because no matter what we found might be a prefix match for something else. So, different flags in an organizing semi-state machine. So at this point, what we can say is, if the thing we found is an exact match for exactly one kind of keyword, we can bail, right? So if token types.can is greater than 1, there is ambiguity on the match, so we can't do anything yet, so we need to look at the next one. So now we need to consume white space. We need to consume all the white space until the next thing is not white space. And I'm probably going to move that next stuff back to where it was previously. So that goes back to there. Actually, let me just do a quick... yep. Discard that hunk and discard that hunk. So drop those back to how they were before. Okay, that's cool. Reload it. Yes, we want to reload it. Okay, so I'm going to put a private void skip whitespace. And so all this is going to do is it's going to say while switch peak. Is peak a property or a method? Okay, yep, cool. Okay, so peak is a property. So skip whitespace can say, look at peak, and that's where we put in this chunk here. Can we retrospect a little? As far as I'm aware, you have some reader and controller, right? Controller has some set of rules, and reader always return next one or more, never last or before. Yes. So the reader and controller is maybe a little kind of misleading. I think one of the principles that we're looking for here is we don't want backtracking. So you only ever look at basically everything you've consumed so far yields an unambiguous grammar. You never need to refer back to something earlier, so you're always doing it by looking ahead. All right. So that should consume any amount of white space. So we'll drop that in there. That will handle consuming all of that. There we go. And so now we get down to our tokenizer thing. So that is that token types equals keywords dot match lexeme, skip whitespace, and while token types dot count is greater than 1, and peak next. Okay, this is looking pretty good. Because that's the same there. We've basically got this loop structure in here now. So let's stick that in a loop. So we're going to say, right, well, that is that. That's next. That can skip whitespace. There's that. Lexeme equals source current. Token types equals that. At that point, if... yeah. We have one command that consists of several words in whitespace. Okay, so the example for... say, in some languages, you'd have this, if x is greater than y. In Rockstar, it's if x is greater than y. And the reason why it's difficult is that if x equals y becomes if x is y. And so x is y and x is greater than y mean we need a look ahead in the scanner. So when we see an is, we're like, right, what's next? Is it an identifier? Or is it a keyword thing? Language keyword. Okay. So skip whitespace. Consume the next thing. Stick that in the lexeme. Token types equals keywords dot match that. Now at this point, if token types dot count equals 1. Can I propose using a commands control array? It's not that I don't welcome the suggestion, it's that I think you trying to explain to me through YouTube chat what a commands control array is probably just going to frustrate both of us. If you can point me at an article or a blog post or something that explains what it is that you have in mind, then I can take a look at it and see if I can figure out how to incorporate that into what we've got here. I'm absolutely happy to take a look. Maybe adding another method that scans the entire line, removes multiple spaces with regex. We're going to stick with this way for like another half an hour and see how much progress we make on this. At the point we reach for regex, at that point I'm like, we may as well just do it with a parsing expression grammar, because if we're using expressions to handle the parsing, then there's no point to me doing it the long way round. So we've got as far as this. That's all. So this we can uncomment now. That comes out, that comes out, that comes out. There's that. There's that. There's that, that. Let's put that in its own file so that it doesn't keep getting in the way. Skip whitespace while peak is off and you're next. Lexeme equals source start current. Keywords equals that. Keywords dot match lexeme. If token types count equals 1. Yeah, Eugene, I absolutely sure that you can see something here that I can't see, and it is frustrating you that I cannot see it, but unfortunately the nature of streaming is very asymmetric. I mean, I guess there's a theoretical way I could grab someone on something like Zoom or StreamYard and we could do a screen share and live stream the thing that way. That is maybe something to revisit for a later stream. All right. Okay, so this is then going to be the difficulty, is that if we end up consuming an expression like so if x is greater than y, so we consume the is, that's cool. We look at the next bit, we consume greater, that's cool. We consume than, that's cool. Then we consume the y. That point we're like, no, okay, that's enough. Back it up. So we need a peak method, which is gonna give you, it's gonna advance and give you back everything until it gets to the next white space. Because we need to be able to look at the next token. Yeah, we need some. I think we need a way of looking into the next, pulling the next alphanumeric sequence following the current thing, pulling that in and seeing if that gets us anything. But that doesn't actually advance the current pointer. Right. So greater is keyword, yes, save to stack of commands advanced. Then is keyword, yes, save to stack. Why is keyword, no, do something with stack and clear. Yeah, so the difficulty, okay, I like that. I like that suggestion. So Eugene suggested that basically if you find the next thing looks like part of it. So the difficulty though is, one, it's not just a so this That's not 3 keywords. That's 1 keyword that has spaces in it. This is why a lot of the kind of theory, because most languages, you can't have spaces in the middle of keywords. It's just not a thing you can have. And so the thing is, you need to be able to consume chunk after chunk after chunk, but based on a list of defined tokens that you might want to be matching it against. Okay, so we need read next. Alphanumeric token. Okay. If it matches 1 keyword and is a prefix of 0 keywords, make the users wrap their variables in quotes so the string is a variable and you're only looking for quotes then. Yeah. But we can look at the stack afterwards and work with a slice on it. So we just make the tokens match some arbitrary map of meanings. Like, is it part of a keyword? Yes or no. So I think I don't know that we actually need a stack to do this. At least I think there may be a way of doing it without using a stack. Because the hard part is, without looking back on it, how do you know when to stop putting things onto the stack? So we've got this. If it matches 1 keyword, then we've found a I'm going to invent a new thing, key phrase. So a keyword is a language syntax with no spaces in it. A key phrase is a part of the language which has spaces inside it. If it matches 1 keyword and is a prefix of 0 key phrases, yeah, it is. A keyword is a key phrase with only 1 part. So maybe we just call them keywords. I'm just, it's that whole thing of can you make your life easier by making up words for concepts which are very specific? So Jake, if all keywords have x as the maximum number of strings, why not set up the scanner to scan x amount while skipping spaces, then checking against keywords? So you mean pull in like the next 3 tokens and compare that to the keyword list? We could do that. It would work. It would mean we were scanning things we didn't need to scan if the first thing was a very unambiguous keyword, I think. Yeah. Okay. Yep. Yep. Yeah. So Eugene's talking about using flags. So yeah, HTML, embedded script inside HTML is a famous example of this, where you've got a little chunk of code like this. So you've got script, and then inside there you've got if x is less than y, you do something, and then you've got /script, and that mean completely different things. And so when you get into the script, you set a flag that says you do. I don't think we need to do that because we don't have anything in here where the same symbol means something different in a different parsing context. So what I'm trying to think here, is there ever a scenario where, because, okay. So we got four different scenarios here. Bring VS Code back up. I had a VS Code window, there it is. So we've got x is greater than y. We've got x is y. We got x is greater bad, and we've got x, actually maybe only 3 scenarios. So in every scenario we've consumed is, and now we're looking at the next thing, but in this scenario, poetic literals is a different parsing context because with a poetic literal we know where it ends. So something like the canonical desire is a love-struck lady killer. Now, okay, so is here is a horrible example, and it's actually one of the things. So Rockstar 2.0. It's going to be desire is like a love-struck lady killer, which is going to be a hello, White Panther. We have not yet had any random chicken emoji cropping up in Rockstar, but you never know. The day is young. So what this is going to do is this is going to be the poetic literal itself. This is going to be the keyword which initializes it. But anyway, to go back to the original question, once we know we're in a poetic literal, we just skip forward to the end of the line or the end of the statement, which is going to be a punctuation. And that gives us a really easy way of working out how much we have to consume and when it's time to return a value and skip out. Whereas what we got here is more complicated because we don't know where the end is. And so the end, well, we can kind of detect the end. The end has to be an... So that one there is good, and we return an identifier. So return token type dot greater do not consume y. Yep. That one is good. We need to return token type dot equal do not consume y. And this one, this is probably a syntax error. This, I think, is... yeah. Could you have an identifier called greater? Could you say greater is 4? If x is greater, that will be true if x is equal to 4. And in theory, there's nothing stopping you doing that. It just might be really, really stupid. So the reason it's not similar to parsing math equations, Eugene, is what we've basically got here is there isn't like a canonical order of precedence. We've got a rule that says, hey, if you see is greater than, if you see these 3 tokens in a row, then just because we decided it, those 3 tokens bind tighter than any operator precedence ordering. It's just about that. It's about identifying a keyword which has multiple elements in it. So what I want to do, I think, is right, that's going to blow up. I think it's reasonable to conclude that if somebody types that in, it's just going to say we don't know what this syntax is. This is not valid, because what the... Okay, x is greater. That's good. Return token type is equality. Do not consume greater, because sorry, there are funny things happening on Twitter on the other screen. Another suggestion, what about attaching an underscore afterwards like then? So when we detect it, we can read the next chars and yeah. No, because you don't put underscores in lyrics. That's the North Star, the guiding principle of Rockstar should be that absolutely anything you might want to do in your program, you can express in a way which looks like ordinary, completely regular song lyrics. Doesn't require any unconventional punctuation, doesn't require numeric literals, doesn't require, details. Sorry, bizarre syntax or anything. It looks like ordinary lyrics, and so having to put things like underscores in to resolve ambiguities in the syntax kind of breaks the point of doing it in the first place. All right. We attach it while reading the program. Oh, yeah, okay, so behind the scenes. Yeah. Maybe. I probably think this... I want to stick with this approach. I think this is going to work. So x is greater than y. That's good. We return token type greater. Do not consume y. If x is greater, that's good. Return token type dot equal, and greater is an identifier. So whatever comes after that, now... Yeah, this is where we get into So the if statement here evaluates to the end of the line. Because that's the sort of slight difficulty we got into now, is if x is greater, what can follow that? And yep, 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 yep. Okay. I think so the difficulty here is the look ahead thing. We need to be able to throw it away, which means we need to. I sort of can't rely. So peak and peak next here. What they do is they look at the one after this and the one after the one after this. So current always points at the thing we haven't dealt with yet. And so we need a look-ahead method that says if we match something, we've got to be able to implement current by that much. I move it to the end of the chunk we just consumed. Which means it's no longer just a straight linear scan. Don't look ahead, look behind and current, as look ahead can end badly in certain cases. So yeah, so this scan identifier, I think, is gonna potentially have to return more than one token, because we could have a scenario where it except we can have variable names with spaces in them as well. All right. We're gonna figure this out. This is gonna work. We're gonna figure out a way of making this work. So we're always looking at what have we already consumed and what have we not consumed. And this is the difficulty here, is think we need to stash the lexeme we had seen previously. So at this point, we could be a straight identifier. Like, I don't know. Or it could be that. So the question is, did we have a valid match last time? But if we did, this will have been unambiguous. So is greater than would be a compound keyword with only one match. So basically at that point, yeah, if we get down to the point where there is a single match, it means that everything we've consumed so far exactly matches what we have. Okay, yeah. So this is what happens next. So if tokens count equals 0, then let's assume that we're not going to get this, because at this point we'll have got that far, found an unambiguous match, and bailed out. So the only time that tokens is going to be 0 in here is if we have something like is some variable. Now when that happens, we need to return two things. So it could be that, or it could be, yeah. All right. Okay. So what we do each time we tokenize it is we say, right, whatever we've matched so far, could this be a keyword in its own right? So if we find is, then we've got multiple candidates for that. but we need to capture that. And so what I'm going to say in here is token types equals that. And ba, 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 ba. There can only ever be one complete match. So let perfect match, no, that's not even a thing in this language. For perfect match equals token types dot first or default. T goes to T dot value equals match type dot complete. All right. So that one is, did we have a complete match? If we did, it'll be in here. There will never be more than one. So it'll be that or it'll be null. And null is weird because calling first or default on a dictionary is gonna, we need an explicit thing in here. Hello, Cinciat. Welcome. Fun and games. How do you parse identifiers with spaces in them? I'm just trying to think. So first or default when applied to a dictionary won't give you back null. It'll give you back, unless, can I tell it to do that? No, I can't tell it to do that because null is not assignable to key value pair because key value pair is a struct, I think. So I need to give it a something that it can kind of latch onto to determine that it didn't actually find anything. Okay, you know what? Just to test through the logic, I'm just going to make that a where.toList. All right. So that'll be a list that contains one thing or no things, but it's fine. So if token types.count equals 1, and that okay, let me try this. Yep, that returns that lot. Then otherwise, if we have more than one partial match, well, at that point, we want to go around the loop again, don't we? No. Since you had your question, there are variables which have a couple of fixed prefixes, but there are also operators which are English phrases with spaces in them. So x is greater than y. Basically, we need to pick out is greater than and parse that as a single token. And the difficulty that I think we're going to get to is we're going to have expressions like if my variable is higher than your variable. So to parse that, the actual parsing thing we are going to need is, so that's going to be a keyword there. So this is going to come out as a conditional expression Let's recap. You look into the selected token. If that token is a keyword, set flag and add keyword to slice. Yeah. Except that, right, what I don't currently have in here anywhere is I don't have a dictionary of things which are bits of keywords. I'm going to add, okay, so let me show you what we're going to plug in here. I'm going to have a token type dot equal sign. What did I call it? Let's So this is what the scanner has. This is the keyword definition that it's working with. And actually, even this, I'm not 100% convinced. Because there are multiple aliases that can stand in for that. And with a expression grammar, you can make that a sub-expression. You could try matching the longest one first. So the question is, how much do you consume before you decide the thing you're looking at doesn't match anything? And because the language itself can have arbitrary numbers of spaces and things between these expressions, figuring out how much to chomp before you decide that you've matched something and you haven't matched something. Hello, newbie man 1337. I'm glad you're enjoying the talks. Yeah, making videos is there are days when it's a lot of fun. there are days when it's complicated. So Mumi says, sounds like a prefix tree. Yeah. Okay, you know the length. If my approach, you can compare the length of a slice to a known length of commands with spaces, and then by composing string compare selected. Yeah. So the more I work on this, the more convinced I am that an expression grammar is a much better way of coping with Rockstar than a tokenizing scanner like this one. But I'd quite like to get it working before I throw it away, otherwise it's going to feel like giving up, you know? So... Okay, so the headache comes because if we consume something like that, we need to return token type equal, but not consume greater. Because greater, we need to then bail, we want to drop back out and not look on the stack, and the only way to do that is either we need to return 2 tokens from here. We need to return the fact that we found a keyword, or we need to stop. And I think we need to do look ahead. I think the only way that this is going to work is if I can look ahead at the next alphanumeric token in the stream and consider that in the match. And because that way, if it isn't a match, then we haven't advanced past the point where it makes sense. We're still going to bail out early. So on this one here, we're going to get X, we're going to get is, we're going to look ahead at greater, and then we need to look at to the next one after that. And only if the next thing after that is not the than keyword, at that point we know we haven't got anything, and so we bail with the last complete match that we found, which is going to be is, because that's the only thing we found on the way to here that actually gives us a return candidate. Okay. All right. So can is be in 2 different expressions. Yes. If what you mean is can the same keyword, yes it can, because we've got, you look at the example here, we've got x is y, and we got x is greater than y, and those are both valid. We'll get there. I'm just figuring, like every time you try something that doesn't work, you learn a little bit more, or you get another little perspective on the shape of the problem that you're trying to figure out. And so you just kind of, it's tenacity. You got to keep chipping away at it and chipping away at it and figuring out what you can do. And the sort of big part of the difficulty here is, yes, a symbol can consist of multiple tokens separated by whitespace. And also there's prefix ambiguity, because is and is greater than and x is less than y. Those are all valid expressions. And so the operators that, or the symbol there is greater than, or the symbol is less than. And the key is identifying the symbols. Well, yeah. Stop. Stack will work. In any case, you'll have either a keyword next or a non-keyword name. Bingo. So will it? So read the next alphanumeric identifier, push it onto the stack, and then what? Because we can't determine whether the next thing we look at is a keyword without also knowing whether the part we are currently looking at is part of a keyword or a symbol, like a multi-word symbol. Marie has a silly question. There are no silly questions. All questions are valid. What's the question? When you see is greater, is it possible for Maria, I don't know if your question is awaiting part 2 or if it got clobbered by the chat filter. So when you see is greater, is it possible for that to end in not being a keyword, or is it an error to end it otherwise? So there is this little scenario here. It's not entirely clear what the right thing to do is. If you have an identifier which is a substring of a symbol, can you use that substring as part of or use that substring as that identifier as a variable name in its own right? And so could you have a variable called greater, which would mean that if x is greater is going to be variable operator variable, or identifier comparison identifier, Or is that going to be a syntax error? And my hunch is that it should be valid. My hunch is that it should be allowed, because that way introducing multi-part symbols in subsequent versions isn't going to break stuff that previously worked, because somebody picked a variable name that has now become part of a multi-part identifier. So yeah, it's not a silly question at all. It's a completely valid question. You get all kinds of weird edge cases when you have language syntax that works like this does, and yeah, there's no like obviously correct answer, because both approaches are kind of weird. One is like, well, of course you can't do that. So make every word as an internal token, then compose a complex expression by adding them to an array, not just a string. That way you can check each time on part of a found keyword. So you're saying read each word in the input, put it into an array. That way you can check each time on part of a found keyword. But then okay, so make every word an internal token, compose complex expression by adding them to an array. So you're saying that we have the keyword matcher knows that there's a keyword which has is as the symbol 0, greater as symbol 1, and than as symbol 2. So the language definition is arrays of tokens, not just strings. Sorry, and then equal to 4. You've lost me. I suspect that even if we were physically sat at the same terminal and you were typing this stuff in and I was following it as we're going along, I would still be struggling a little bit to keep up with what you're proposing until it clicked. Yeah, if you've got a Git link or something, send it over. I don't know if you can post links. If you can't post links, then I can drop in a Discord, or you can send me a Twitter DM or something. Yeah, if you've got an example of this that works, I'd love to take a look. I have a match method that checks for a sequence of characters. No, I have a match method that checks for one character. And is not currently being used. So match in the textbook example, in the Locks book that I'm working from, is used, for example, if you found a equals, you need to see, well, is this a equals equals or just a single equals? Is it assignment or is it equality comparison? And so that's what the match thing uses, but I don't have any two-character operators in here. Hello, Stony Eagle. Welcome to the stream. How you doing? We are having fun and games with multi-part identifiers here. Okay. Right. Okay, we're going to try something else. I think all of today's code is probably going to get thrown away. I think this is very much about trying to figure out a reasonable way of doing this. Stony! All right, hello Stony, how you doing? So what do we got in here? I got a private string. So I'm going to pull out a thing that just gives me the next alphanumeric token from the input stream by doing a look ahead here, but does not actually advance the... yeah, match was character based. What if it was made token based? So match, you tell it what you're looking for, and if it finds it, it consumes it and gives back true, and if it doesn't find it, it consumes nothing and it gives back false. What I'm going to do instead is I'm going to build a look-ahead method that will give us the next... It'll basically look ahead to the next token in the stream. And or the next non-white space sequence. It'll pull that out, tell you what it is. And if that matches something at that point, we're going to advance the state of the parser. So Eugene, you're thinking, well, like, what, you're trying to post a link and drop something in here. What is the easiest way of doing this? So you want to send me a Twitter DM? That can work. If you're on Twitter. Oh, yeah. Got a Twitch. I think you can post links on Twitch. Try Twitch first. It has lower latency as well. If you're on Twitch, I get the chat messages come through quicker. Yeah, there we go. All right. Okay. Okay. Line 38. I have no idea what I'm looking at here. All right, what do we got? Okay, so keychars is a map of bytes to strings. And so this thing here is saying that the pattern style is 60 plus 115 plus 32. So 60 plus 115 plus 32. Right. Let me keep doing what I was doing for a minute. That's interesting. Thank you for sharing that. It'll take me a little time to figure out what it's actually doing. Let's have in here private string read next chunk. Private string look ahead. So what's this going to do? This is going to take so say var I equals current, and while I is less than source.length, if current I dot source I. Switch on source I. Yeah, that'll do. Hello, Randy Bobandy. It's we're having fun in games trying to parse languages which should not be parsed, because all of the textbooks say don't do that. If you do that, you'll have a really, really bad time. And we're like, YOLO, we're gonna do that anyway. All right. It's all right though. We have Pingvin flavor Norwegian salted licorice, which is the secret to all successful compiler engineering. So we're gonna switch on source I. So I need to do a gribbly thing here. If so if source I is alphanumeric or source so look ahead. I need to know how long this is, including any space that gets ignored in the process, because I need to know the length by which I increment current if I have actually found the thing that I'm looking for in context here. So I equals current while I is less than source dot length, while source Thank you. So while I is less than source.length, so that's our while loop. So what have I got to do here? I gotta skip whitespace and then consume alphanumerics. So except I gotta increment the line counter if in the course of doing this. Oh boy. Yeah. All right. We're going to assume that multi-part operators cannot have line breaks in them. You can't have is new line greater is new line then. Okay, that seems like a reasonable compromise. So we've got a while source I is whitespace. What? No. Yes, that. So white space for the purpose of the exercise is spaces or tabs. Okay. So while source A is white space, I++, then if the first thing after the white space is not alpha, identifiers have to start with an alpha. Okay. No, I don't want to continue. So if increment that, while source I is alphanumeric I++, and then all right, so that's while true. Var. Well, what even is it? It's a thing. It's lexeme equals look ahead. You want to return what you find by looking ahead, but you need to figure out what of the look ahead you actually need. So I'm just gonna go through this and see if I can get something here sort of vaguely working. Or at least working to the point where I can build it, I can stick a test on it, I can step through in the debugger, and I can see what it makes of everything. Let's chomp out all this stuff here, which is currently confusing whatever we got. So I'm going to chomp that lot, comment all that out, lexeme equals look ahead, and then I'm going to say if lexeme so if look ahead returns nothing, then return I don't know what. All right, so first thing I want to do is I want to see if look ahead is gonna give me a legitimate advance. So I'll say current plus equals lexeme.length and return token type dot identifier. Okay, so what this should give me is I should be able to throw little snippets of code at the scanner and get back a bunch of tokens for a thing. So scanner tests is there. Does this code even build? Let's see how badly. Yep, 2 succeeded, 1 up to date. All right, so let's have a fact here. Public void scanner look ahead finds identifiers. And cool, Eugene, you can find my contacts on the channel because sorry, Randy's just said I tend to write an interpreter of a squirrel in C# for fun a few years back. Yeah, the things folks like us do for fun, yeah. So what do we got? I got a new var source equals Alpha Bravo Charlie Delta. Then we are going to say var tokens equals new scanner source error dot tokens dot to list tokens dot length dot should be 5 should be 5. But now I've got that, I can stick a breakpoint on that line. I can right-click that, and I can debug a test. And if this works, all right, there we go. Source surf 11, step into that. That's cool, that's cool. Fine, fine, fine. While not is at end. Scan token, skips white space. That works. Start equals current. Current is at 0. We got that down here. Let me bring up, okay. Switch on C. C is an A. It's not a digit, so C is alpha. Return scan identifier. Yes. Yep. Step into that. Var lexeme equals look ahead. Step into look ahead. I equals current. Yes. While source I is white space. What is current now there? I is 1. If that's alpha, yes. While source I is alphanumeric. 1, 2, 3, 4, 5. Bail, source, current. So we have got lexeme equals... Okay, that's interesting. It's chopped off, of course it's chopped off the leading A. We can fix that. Alright, so let me drop in on the line I want to break at is here. Boom. That one, stop that. Stick a breakpoint on there. And there we go. Right click. What do you mean no covering tests? I'm literally looking at a test. Okay, let's restart the nCrunch engine. The other thing has just occurred to me, there is a completely different approach that we could take to this, which would be to have basically a branching scanner. So as it scans, linearly through the input source, every time it finds something that's ambiguous, it just basically splits the timelines, if you like. Yes, this is on a public repo. This is on github.com. I'll stick the link in the chat in a second. Repositories, Rockstar 2.0 spikes. So this is where I am throwing all kinds of... is this public? There it is. Yeah, there we go. This is experiments. This is throwaway code. This is stuff that is going to be used as a reference point to figure out things that work, but not necessarily actually used for real. I am really confused as to why... yep, operator tests, amazing scanner tests is fine. I'm just going to hard rebuild the solution. Something has got twisted here. Okay, that rebuilt. I'm going to comment out a bunch of tests. There. Because we are nowhere close yet to the point where it makes sense to try and run any of those. Okay, cool. So what do we got? New scanner is on there. Jump into that. Let's jump forward to that breakpoint. Lexim equals look ahead. Jump into look ahead. Current equals that. While source at I is whitespace. If source I is alpha, yep. All right. Lexim is still alpha. Why is Lexim still alpha? Because I'm returning the wrong thing. I don't actually need to look ahead. That should be I equals current. That should be current minus 1. What do you mean you can't do that? Yeah, you can. All right, run it again. So something that I've just done here has completely, like, chronically slowed down the way the rest of the tests in this solution are running. Run all tests manually. Okay, there we go. Switch that. Yep, that's cool. Right. Restart the ncrunch engine. Ncrunch is very, very good, except when you throw crap at it, in which case it can get confused. And because it's a continuous test runner, it's running all the time. Right, there we go. Doing right click that, debug, cover and test in new task runner process. Let's take a look at what the look ahead here is actually doing. Lexim equals look ahead. Lexim is now alpha. Yep. Okay. Yep. 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 Those need to be the other way around. Do they? Yes, they do. Okay. Lexim equals look ahead. Yep. I'm gonna stick that there, take that one off. There's that. So what do we got? Lexim is Bravo, Lexim is Charlie, Lexim is Delta. Okay, so look ahead is incrementing current too much. Why is it doing that? How does that scanner look ahead finds identifiers? Pin that test, and let's run pin tests automatically. So that should rerun every time I hit it now. Interesting. Why is ncrunch struggling to run? I don't have anything pinned. It shouldn't be running anything. Stop. Okay, restart. I've messed something up in here and it's confusing the test runner, which is making life very complicated indeed. Yeah, might need to restart Visual Studio. Shouldn't need to restart Visual Studio. Might need to restart Visual Studio. I mean, it's possible I have an actual, honest, infinite loop in here somewhere. Bye-bye Visual Studio. Back in a minute. Okay. 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 Engine is initializing. Okay. I'm going to comment out a whole load of stuff. Right, that's all out. That's all out. Scanner tests. That's all out. Operator tests. That's all out. Rebuild the thing. Let's see if we can get this down to the point where there is one single test, and when I ask it to run it, it runs it. Okay, that's fine. Because I need my dummy parsing error handler in there. There. Timeout of 60,000. Something in here's got an infinite loop. And I think I know why. Okay, good. Right, that failed immediately. So, So Eugene says, sometimes imagining energetic music helps me tune the brain. So the irony about streaming this stuff is normally when I'm coding, I have music cranking out. But for whatever reason, I don't tend to do that when I'm streaming, probably because of the... I mean, I guess I could try it. On the one hand, there's the whole, you don't have to listen to my kind of music, which you may or may not enjoy. On the other hand, there's the whole copyright takedown because Twitch is like, you violated the DMCA with all your musics. And two, I'd need to listen to it in headphones. So the mics didn't pick it up. But again, I think that's probably something we could live with. Right, where do we get to? We got to here. This is blown up with that kind of stuff. So let me step through and see what the problem I got going on here is. So debug covering test, that's fine. Okay, we're going to step into that. That's cool. So lexeme.length is 5. Lexeme is Bravo. Lexeme is Charlie. Lexeme is Delta. Return token. What's token going to do? It's going to step into that. Current here is now 26. Which is wrong. How did that get to the... So what's happening here is on the very last iteration of that look ahead, it's actually bouncing off the end of the array and giving me something that shouldn't be possible. So... yeah. Okay, so that's fine. Bravo, Charlie. Okay, so that's Delta. What do we got on here? Current is now 21. And Lexeme is Delta. Should current be at 21? It's still copyright violation, but the copyright holder would need to catch you in the act. Yeah. Sounds to me like maybe we need to get some Winamp on up in here. Right, why is this flown off the end? What is going on? So return token type dot identifier lexeme.length. That's actually probably so. Let me see another thing we got in here. That we know why that's blowing up. It's blown up because on the last one, it's jumping too far forward. So if I do that. Okay, so that, if I put the extra space, so there's an off by 1 error somewhere in the calculation there. Let me just stick a breakpoint on that and right click that and debug that because I want to see what I get out on these tokens here. So we're going to jump on, yep, that's fine. So tokens is there. We've got alpha, okay, cool. So we got a trailing space on the end of the lexeme here, which is not right. Okay, so I'm consuming too much. Okay, yeah, that makes sense. We do, so during the lockdowns and things, we did actually try to do live music on streams and that kind of stuff. It did not prove terribly successful because latency and the speed of light makes things incredibly complicated. Let me see if this thing is going to work. Oop, hang on. I mean, I've almost certainly got some stuff in my library of old school MP3s that Twitch's algorithms have absolutely no idea about. Let me configure some audio stuff here. So I need audio properties on that. And I'm going to want audio output capture. That's there. That one there, if I switch that over, no, that's got latency. It's impossible to talk when you hear your own voice a couple of milliseconds behind what you're actually saying. Output capture is on. And let me do a quick properties on that. That's cool. So you know there's a thing in OBS, there's a ducking sidechain compressor somewhere. Yeah, there we go. So we can stick a bit of compression on that, set all those to the defaults. No, switch that back, that's there. In theory, this means that when I talk, it turns it down just a little. We're going to do some experiments now with using audio on the stream, and I'm going to get all y'all to tell me if this works. And this is going to be hilarious because there we go. That's that. Winamp. Definitely Winamp. There we go. Media library. Where's the good stuff? Properly old school here, because I'm pretty sure that none of the streaming things that I've got give you permission to stream stuff. But let's see what we can do here. What would be fun? What I don't have in here is anything algorithmic. There we go. It is quite loud. I have actually done that, Surly, more times than you can probably imagine. All right, let's see if we can figure out how to make this thing work. Have I looped that again? Yep, that's looping. All right. Yeah. So how do we tokenize the identifier, and how do we make it so that the Lex's current character is left in the right place when we finish consuming a multi-part token, which I'm doing by looking ahead.
Here in Babylon today, the dome temperature will be a comfortable 28 degrees with low humidity. More news at noon from Meridian, the voice of Babylon. Talk to me.
How on earth is just iterating through a string and making sure that it doesn't blow up this complicated? After the if we need an else, because after delta it doesn't get any alpha characters, but it still returns current -1. Let me see what that does with this. Yeah. Okay, so that's working. That's cool. Should be 5, but was 1, but that's alright, because all we're getting there is an end of file. If we just give it an A. Alright, that blows up straight away. So let's step through that, see if I can figure out why that's not working there. Yep. Current is 1. Source I is 1. Well, if source... Yeah, keeping track of indices is a pain. You know what? Yeah, all the look at stuff's commented out down here, Eugene. Alright. Sorry, no, that's what I'm working on. So all the stuff we were working on like an hour or two ago, I've commented that out. Randy, Bob, Andy, absolutely share possible solutions and snippets. Alright. Yeah, that's fine. That's fine. Right, let's see why that's blown up.
Industries. Please submit your personal access code on the keypad provided. Thank you. Please face the optical security scanner. Retinal identification complete. Good morning, 327.
You know what, folks? If anyone out there wants to share code snippets and bits and pieces of stuff like that, let me see if I can share a link. We have a Rockstar Developers Discord, believe it or not. So the thing you got to realize about the Rockstar Developers Discord, nobody knows who set it up. Somebody created it after seeing a Reddit thread and went, "Ooh, cool! Yeah, let's put stuff on here," and jumped in and did it. And they set up a bunch of server roles, including Rock God for me, which I did not particularly want to ask for. And now we can't change it because there's some weird quirk that only the server owner, even though I have like admin and everything, only the person with the actual like server ownership can change the highest rank role, and we don't know who that is. They've disappeared. So yeah, fun and games. Right, where did we get to? We got to... Ah, that's dumb. I shouldn't have done that. So we could do that. All right. Right, we're going to do this again. Old school, completely from scratch. So I equals current if Okay, so the music is cool. The only thing is I need to tweak... So these headphones are the stereo phones I use for practicing the drums. So they are incredibly good at noise isolating, which means I can't hear my own voice, so I have no idea how loud I'm talking, which makes it a little weird. Right, how the hell am I getting out of range errors just trying to increment a string? Right. Okay, so we got lexim.length. That's correct. Okay, so we shouldn't be incrementing current by lexim.length. We should be lexim.length minus 1. Because we've already advanced by 1 character, because we consumed the A in alpha to get to the point where we realized we were looking at an identifier scan. Yeah, whatever. Come on. All right. Come on, come on, come on, you can do this. I'm expecting that 3 to turn into a 4. And not expecting the whole thing to go into another ridiculous infinite loop for no readily apparent reason. Well, this is fun. So when I have that like that, the test fails immediately. When I add a third token, it goes into an infinite loop, and there is no reason I can think of at all why it should be doing that. Let's stick another breakpoint on the look ahead, see if I can figure out where that's blown up. Yep. Alright, debug covering test. Let's see what we can see. Okay, look ahead. Lexim is wrong. Single character identifier. So we're having fun and games on the Discord right now, because we have a Discord server for this that is not letting anybody post anything interesting. All right. Da 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 da. All right, what do we got? Okay. Okay. So that there is the stumbling point. That's the crux of it. Because in case identifier matches a keyword, we don't know. We don't know if the identifier matches a keyword, because we may need to read the next keyword and the next keyword and the next keyword, because we have, or the next, identifier, because we could have keywords composed of multiple identifiers. Okay. We do know what they are. Yeah, the multi-part identifiers are predefined. Right. But the difficulty is that unless you want to end up backtracking, we need to look ahead without incrementing the current index on the source, because if it turns out the thing we're looking at is not a keyword, we want to be back where we started so that we can fall through to the correct clause from elsewhere in the parser. Hey, DKW Daft. Yeah, the weekly videos, it's a new thing. It's an experiment. Not done anything quite like that before. We'll see how it goes. Right. So look ahead is currently blowing up because if we have a single character identifier, it can't cope. The fact that the test is going into an infinite loop at the drop of a hat is not helping.
And finally, to recap on the Meridian headlines this morning.
The music is an album called Babylon by a British rock band called Ten. That
Despite the lack of motive at this stage,
fantastic songwriting. I think the production's a little muddy, a little too much kind of splashy cymbals, but that's what the music is.
Jan Jarrett and was an employee of Cryotech Industries. The spokesperson
Right.
for Cryotech this morning said, "It is tragic. Miss Jarrett was a model employee who will be sadly missed."
There was once a time long ago when true love drew man and woman together. She was all he wanted to know, and he swore that he would love her forever. So
Knowing the max count of tokens that keywords contain, and what about a separate bool recursive function takes a stream of tokens, recursive check the number of tokens that follow the to go without incrementing calculating scanner. Yeah, that would be certainly another approach. At the moment, it's really just reliably being able to pull out tokens from the stream without incrementing the current value in the scanner in the process. Okay, okay. So to me, the single biggest thing in whether developing software is enjoyable or not is the feedback loop. How long does it take to discover whether the thing you just did is working or not? And having a test runner that is just going into an infinite loop constantly. I mean, it's not the test runner, it's my code. But, right. Let's debug that, see if I can figure out what the f is going on here. Nothing. Doesn't work. Doesn't start. Doesn't run. Doesn't hit any breakpoints. Right. Folks, I am now getting suggestions on how to do this on 3 different channels and 2 different sets of DMs. I am therefore respectfully going to ignore all of them in favor of looking at my own code and trying to figure out why it's not doing what I think it should do. Okay, so there's that, there's that, there's that, there's that, there's my scanner. Okay.
And I swore that I would love you forever. So the light fades the colors of life when it's gone. Like a lost ship on dreams.
Waiting for engine resources to become available. Alright, you know what? The hell with that. Alright, new scanner, new parser, yeah, okay, var Lexim equals, look ahead, yes. Yes. There. So the second call into scan token has thrown the whole thing for a loop. Alright, let's try that again. See if I can figure out where it's actually blowing up. Okay. Lexim equals look ahead. Right, that's fine, that's fine, that's fine. Current 1. Current is now 6. Which is correct, I think. 0, 1, 2, 3, 4, 5. Yeah, return token type, that's cool. Alright, okay. Scan identifier, right. Scan token, yield return token. Yeah, okay. We're not at the end. Scan token, yes please. Skip whitespace. Ah. Stupid. We need to advance. Otherwise it's not going to work. Right. Right, look ahead. Boom. Run, 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 run. Boom. Okay, so at that point we've called into a scan identifier, but we called into a scan identifier based on... where's the call stack? Here. So scan token... I should really have used more sensible input, shouldn't I? Where's program.cs? AAA, BBB, CCC, run. Does the getter of peak increase? No. Next increases the character pointer. Peak doesn't. So peak is look at the next thing, but don't increment because we might not want to move forward depending on what we found. Next will unconditionally advance to the next one and return whatever the next character is. Alright, so Lexeme at this point... Okay, Lexeme is empty, which means scan token on here... That shouldn't be here. Okay, so we got AAA, BBC, CCC. So look ahead. Yes, yes, yes. Yes, yes, yes. Does continue. Okay, I thought continue explicitly fell through to the next clause in a switch statement.
Identification complete. Good evening, 327. You are working very late this evening.
Cannot fall through. Yeah. Okay. Okay, so why is this calling into scan identifier? When there is nothing to identify. Let's run that again. Right, boom, there. Okay. Look ahead, there's the Lexeme. Alright, return the token type. C is now B. Okay, cool. Right. C is now C. Yep. That's not right. Okay, A, fine. Yep. Is that end false? It's B. That's C. Yep, look ahead. Consume, return a token type identifier. Is that end should be false. I mean, is that end should be true now. Right. This is getting a long way away from where I was expecting to be by this point in the day. Okay, right. Back it up and think. So I suspect that what I've done here is at some point in messing around with things like consuming white space. That one maybe. Yeah. Right.
Holosuite multi-programs complete. 327. You have no authorization to release prototype.
So Lexeme is AAA.
Of an illegal nature.
Yep.
Command override.
Lexeme BBB.
Submit the recipient details for program
CCC, and now is at end should be true. Yield return end of file. Boom. All right. Yeah, that was the problem there.
Thank you. Please press execute to send. Holosuite data transfer complete.
Let me find some more tunes on here.
Angel 3 to disk. Deleting all backup files as requested. Deletion complete.
Oh, you folks are gonna get a fun little riff through some of my weirder corners of my MP3 collection this afternoon. All right, okay. So I think I've got reliable look ahead working, I think. First thing I'm going to do is stick it in GitHub in case it turns out I have and then I break it. Okay. Right, that's still blowing up. We don't know why. Let's figure it out. Interesting. All right.
Cryotech was once more in the headlines today as two of its directors, Rev and Don Devlin, the two sons of Max Devlin, the founder and president of Cryotech, were found dead in suspicious circumstances at their homes this morning. This brings the recent spate of killings at Cryotech to 3. A spokesperson for the police said they suspected these to be revenge killings, and
Hello,
although as yet could not
Lex.
determine the cause of
I am
death,
dealing with your request.
surrounding the deaths were said.
Loading personal holosuite program Angel 3 from disk. Please take your position. The program will commence in 30 seconds.
Okay, right. So that's wrong. Current should not be 2. Boom, blow up. Yeah, that's fine. Okay, what if I do it with AA? Alright, AA is there. Well, that's not add end. Scan token, look ahead, that's fine. Lexeme.length is 2, current is 1. That should be Lexeme.length minus 1. Because the first character was already consumed because we incremented it. Okay, so that's blowing up, but that's fine. Okay, hello Sander, welcome. So this is me. This is a wall. This is me banging my head against the metaphorical wall. So the big project here is building a parser and interpreter for the Rockstar esoteric programming language in C# so that I can port it to, or I can use Blazor to host it and run that across the board, and it'll run on browsers and all kinds of things. And today specifically, the fun part, Rockstar has keywords and operators with spaces in them. And this proves very, very difficult to handle in the interpreter because most people who design programming languages are like, well, just don't do that. And it's like, well, yeah, we could just not do that, but that would be no fun. So what I'm trying to do is figure out how to adapt a... there's a wonderful book called Crafting Interpreters by Bob Nystrom. And I'm trying to adapt the examples and patterns from that book to work on a language with spaces and variables and spaces and keywords, and yeah. I think we may have just hit a breakthrough. Right, let me grab that test. So let's change that fact now to a theory. And in the theory, I'm gonna say inline data AAAA. So I'm gonna give this a string source and int token count. A is a bad example. Let's choose X. Okay, cool. Index was out of the bounds of the array. Let's see which cases they're broke. Right. Okay, so it's struggling, it's choking on leading spaces now. So scan token, skip white space, start equals current, So start is now 3. And locals source is 0, 1, 2, 3. Okay, so that's correct. So if C dot is alpha, that is X. All right. Yep, cool. Step through there. Step through there. Scan identifier. So lexeme equals look ahead. So this should now be pulling out just the character C. Or just the character X, sorry. So that works. Yeah. Okay, that's wrong. Yeah, no, that is right. That is right. That is right. Current is up to 4. We've skipped all the white space. I think. That's weird. I might take out that skip white space. That seems to be causing more problems than it... find references... Where's find references? Find usages. There we go. There's only one. Alright, I'm going to take that out. You could remove... So, the reason why I'm not... I could do a bunch of stuff here with pre-processing. Like, we could take the file. First, we could run through it, strip out multiple spaces. Then we could run through it, normalize white space. Then we could run through it. We could find all of these multi-character or multi-word keywords, key phrases, symbols, and we could replace those with their canonical implementations. We could do all that. I'm kind of... I'm attempting not to, purely for the bloody-minded sake of doing it without doing that. Because when you do that, what you end up with is a parser that has to run through your source multiple times. So first you've got to run through the whole thing and strip all the spaces. And what the other challenge you have there is if you want to tell someone where the error message was in their Rockstar program, if you've stripped all the double spaces, your view of their source code doesn't match the one they thought they had. And so when you find an error, it's not actually in the same place that they had the error because you've normalized a bunch of stuff. And so to be able to accurately say, hey, that there, line 23, that character, that broke, you can't mess with the file before you pass it into your scanner. So, I'm going to pull a bunch of stuff out of here. So, let's... That goes. No more skip white space. The tokens would store their position in the source. But if you are stripping all the double spaces before you... So the word parse, explicitly the flow that we've got here, is that you have the source code runs into the scanner outputs the tokens are fed to the parser, so by the time the parser gets to see them, if you've pre-processed them in the scanner to eliminate white space, the locations that the parser sees That's all right. So I said, I think I tried to help with the snippet too. Yeah, no, that's cool. It's all interesting stuff. And it's always nice getting other people's perspectives because, you know, sometimes there's a bunch of stuff I just don't know. I have no idea. I'm figuring a lot of the stuff out as I go along. And so having people throw in suggestions, put it this way, I'm always really happy for people to suggest stuff as long as they're really happy for me to ignore what they suggested. That seems to work pretty well. Alright, so scan token, that's in, that's round. I got a bunch of stuff here. That should be 2, yes, it should. And that should be 3. Alright. Alright, this is looking good. Stick it in Git quickly before it blows up. How do I not have a terminal window open? Oh, tune. So this song is it's by a British rock band called White Lightning, and it's a lovely testament to why the internet is a good idea, because I heard this on the radio in about 1991, and I recorded it on a cassette, and all I caught, like I got the DJ saying that the name of the project was As Midnight Approaches. The tape cut off before I got the name of the band or anything, and I couldn't find it. I went to every record shop in town. I even emailed Tommy Vance when email got invented and was like, you played this track on your radio show like 8 years ago. Do you remember what it was? And he was like, I'd love to help, but I can't remember. And then after 11 years of searching, I found somebody in Germany who had put the spreadsheet of their record collection on their like GeoCities page or something. And I found it. And I emailed them and I said, is it this? And they're like, yes, it is. And they made me a copy. They sent me a CD, like a CD burned copy of it. And now it's on Spotify. Like this obscure, they only pressed like 500 copies of this record. And it, basically, if it wasn't for streaming services, it would have completely vanished into obscurity and no one would ever have heard of it again. And now we have streaming and it's out there and you can go onto Spotify and punch in White Lightning As Midnight Approaches. And there it is. It's just wonderful. What a time to be alive, hey? Alright, so where did we get to? We got to here. Scanner.cs. So now I got this look-aheady thing. So var lexeme equals look-ahead. Alright, so we should never get whitespace out of the look-ahead scanner. Alright, that's cool. So now what we need to do is figure out what the heck does this thing mean. And there are 3 scenarios. It matches nothing whatsoever. It's an identifier. So this is where we need to do... Now, this is that thing I was looking at earlier with the keyword matching and stuff. Move that to matchtype.cs. So that's cool. And... Okay, we don't want to increment that yet. Var lexeme equals look ahead. Var token types equals keywords dot match lexeme. If token types returns nothing. Hey, Sophia. Yes, we are doing look-ahead parsing, which they always said you should never do, but there's a lot of things in Rockstar that they said you should never do, and we're doing them anyway. Look-ahead tokenizing to try to pull out chunks of code and replace them with... or try to match keywords with multiple spaces in them. So at this point, what I need to do is... I need to grow that lexeme equals the look ahead. Yes, there are some complications with using. It's not as, it is. And there are 3 different things that is does in Rockstar, so this is going to get fruity. But okay, so what do we got here? I've got a string basically what I need to do here is I need to build chunks of something, but at any point if I realize I've gone too far, I need to throw away what I've got. Backtrack a little bit. Alright, we'll figure this out. So lexeme equals look ahead, keywords dot match lexeme. If at that point so scan identifier. So let's say I have no idea what to call this thing, so I'm going to call it candidate for now. Yep. All right. Token types equals keywords dot match keyword. No, that won't work because the first time through. There, we need to do that with it. All right. I love this song. Porcupine Tree, Halo. Alright, so token types equals if token types.count equals 1, then at that point we can Right, let me just see. I think I've written another infinite loop. Maybe? Oh no, it's fine. All right. So we get the scanner to match keywords.
From the moment I first saw you, I knew I should turn and run, but I can't seem to stop craving the tremble from your touch. And I don't know how it happened, but it happened just the same. That bittersweet addiction keeps rushing through my brain. The wheels are in motion. Time feels frozen. I can hear it rolling. Lord, I
Okay, good. Right, should be output but was identifier, so that's doing the wrong thing. Because shout is a keyword, so let's figure out why that's not working. So let me debug into that test. Boom, yeah, there we go. Lexeme equals look ahead. Lexeme match the word shout. Keywords.match. Token types.count equals 1. Yes. Current plus equals keyword.length minus 1 is fine. Ah, yeah. right, that's all looking good. Oh, this is nice. I'm uncommenting whole blocks of tests, and it's just going, oh yeah, green. All right. Taking a little bit of a country diversion on the music. This is Pin Monkey out of Augusta, Georgia, with an album that's not on Spotify, so no one is ever going to hear it ever again. But it's really good. Right, what else do I have commented out?
It's all over, ain't worth the pain of trying to hold you. You're like barbed wire and roses.
So the unit test, XUnit is the framework, and the test runner is a thing called ncrunch, which is a continuous test runner for Visual Studio on Windows, which I like very much indeed. Why is that not working? Because I screwed this up.
You've done, and I'll show them to you, baby, one by one. I took my chances, I wanted more. I found a rust and I found thorns. You're like a barbed wire and roses.
I've just had an idea. I got this thing in here, which I've just hacked it so that if you give it a file path, it'll open the file, read the file, and use that as the basis to extract the expectations for the test suite. But if the thing you give it is not a file, it'll just treat it as source code and work on it directly. And there could be a really, really interesting way of doing file system I/O in Rockstar. So let's imagine you have the file is I don't know, data.csv. Open the file and then read the file. And so the open keyword, it's a mutator. So you give it an argument which is a string which contains the file path, and after it has successfully completed, the variable now contains the file handle. Read the file into the line. Yeah. Or read the line from the file. So, okay, this could be fun. This could be cool. Because what it does is gives you a way of working with file system operations, which doesn't... Okay, I mean, there's still a certain amount of fun involved in bolting the pieces together. Let me rack up something musical here. I got this MP3 collection, which I've had for like coming up on 30 years now, 25, 30 years, which is just a really, really interesting, eclectic mix of like stuff I've ripped, and yeah. There we go. Bit of progressive rock music from Dorset. Poetic literals, proper variables, operators with spaces in them. Basically every single thing that people say, if you're designing a programming language, don't do this. Rockstar goes, YOLO! Let's do it anyway. Wow, 4 hours. We're going to do about another 10 minutes. See if I can get this this tokenizing parser working on multi-character things. So there's the scanner. All right, so let's throw in a test case here. Everything here is green. So what do I need to do now? I need to add in the scanner tests. Yeah, Rockstar doesn't have file handling at the moment. One of the reasons being that if you're running it in a web browser, what does file handling mean? Like, you say open a file path, what does that do if you're running it inside a... you know, how do you open a file from a website? Like, that kind of stuff. How often do I do these streams? Sometimes I stream every day, and then there'll be things when I don't stream for a couple of months. But I'm trying to do all of the Rockstar 2.0 dev live on stream, and Rockstar 2, I want to launch it in July, so that I can have a big party in August and invite everyone to come and get Rockstar stickers. And so, yeah, anything is fair game, as long as you can sing it. If you can't sing it, not allowed. X is greater than Y. 4. Boom. Failing test. Failing test. Why? Because it's returning the wrong number of... Let me unpin all those tests. Yeah, okay, cool. So that is tokenizing that to be X is greater than. So let's... Cool, okay. Ah, yeah, dope. Okay, is greater than. What do we need to do to parse that? We need a... Right, keywords.match. So keywords contains is greater than. That's there. So there's the scanner. Let's see what happens when we actually hit that chunk of code there. So right-click that, debug in a new task runner process. Boom, that's fine. We probably don't need those. Lexeme equals look ahead. Look ahead should give us X. That's cool. Yep. Return identifier. All right, so far so good. And take that breakpoint off. Look ahead. So look ahead gives us is. So what do we got here? Candidate is empty. Tokens.match. Now at this point, token types.count is 2. Because it said, okay, there are 2 different things this could be. It's either a complete match on the equal sign symbol, or it's a partial match on the greater than symbol. Yeah, Blazor WASM doesn't support file system stuff, so to run this kind of stuff in Blazor in a web environment, we need to come up with a runtime environment for Rockstar which understands what those things mean. So, you know, one alternative might be HTTP, like if a thing is a URL. Yeah, anyway, that's a discussion for another day. Alright, so at this point we've got multiple token types. So I'm going to say in here, if token types.count is greater than 1, at that point, let's grab another look ahead. Or maybe just continue. What's that going to do? X is greater. Hang on, let me start this test run again. So on the one hand, 71 days of total, and we still have the synonym issue. On the other hand, I've been working on this for 3 days now. Like, the entire development time for Rockstar 2.0 is, I think it's all on YouTube now. It's about 17, maybe 18 hours of total development time. So we don't need to, we don't want to consume the is yet. We don't want to consume the is until we're sure that the is was an important part of is greater than. So, No, so the whole thing of which direction do we consume in? Do we consume things aggressively and then backtrack if it was a mistake? Or do we consume things kind of conservatively and look ahead to see what we should be doing? Is, I think, one of the kind of key decisions you make. So Kiki, all right. Okay, so what do we got here? Lexeme, we've matched X. So this is just matching X as an identifier. That's nothing, boom. Return identifier, yeah, that's pretty good. All right, next one in. Lexeme now is, so look ahead is going to give us is. So that's cool. Keyword is a candidate there. Token types keywords.match keyword. That returns at least one partial match. All right. So I think at that point, we continue. So we want to chomp the next piece. So that'll go in a while true. That'll Lexeme. That'll call the next look ahead. Right, let's try that again. I'm not, yeah. I think look ahead needs to take a starting index. So at this point, continue, I need to look ahead, as in I haven't actually decided yet that I'm going to consume anything. So let's do this. Okay. Right. That's interesting. Okay, so debug that one, see what we got going on here. So let's look at it from, that's cool. All right, lexeme X, yeah, keyword. Fine, token types. Nothing. Match identifier. Yep. Step into that. That's that. That's that. Fine. Cool. Okay. Yep. 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 So that's kind of what I'm doing, Sophia. It's not a stack. I'm just sticking them in a... Like, I'm basically just building a string. And if I build the string to the point where it identifies exactly one keyword, I just increment by the length of that string, which has the same effect as consuming it. Alright, so what do we got here? Lexeme equals... is... Okay, so we've got token types has multiple candidates. Keyword.length. Keyword is. Keyword.length is 2. So look ahead from is now set to 4. So there's that. Thank you. 1 second. Yeah, camera has given up. That's interesting. See if we can kick this back into life. Fun and games. So what you folks can't see is me trying to fix a camera. Which of course you can't see, because if you could see it, the camera wouldn't be broken, right? Yeah, no idea what's happened to that. It's never done that before. Oh, hang on. We're back. Woohoo! Oh, thank you. There we go. Overheated. Broken, knackered. USB decided to have a little lie down. I have no idea. Right. So we are here. Right, so lexeme, we've consumed is. Look ahead from is set to 4. Source is x is greater than, so skip the white space. Yes, that's fine. That's gonna give us all that. Look ahead is working. Return source current, that, yep, okay. Interesting. Lexeme is now is greater, which it shouldn't be. Lexeme should just be the word greater, because is... Ah, look ahead is consuming based on current. Okay, yeah, no, that's cool. Right, so what I need to do, I need to modify this. So that will be int start. I equals start, and then we return... There. Yeah, stop it and run it again, and there we go, and debug that one. Okay, lexeme is Huh. Right, let's run that again. I think the is the last two characters of greater. So look ahead from, step in on that, and start is 0. Yeah, that's fine. Source.length 19, that's fine. Yep. I'm gonna break point on that one. So start to I, that is gonna give us back the identifier. Yep, is. Okay. Yep. Keyword.length is hello code with Sean. Welcome to the stream. We are parsing stupid programming languages full of stuff that they tell you not to do at programming language school. Right, look ahead from is now set to 2. Alright, continue. So that's back in there. So now look ahead is going to start at 4. And yeah, okay, so it skipped a chunk of white space. So 0, 1, 2, 3, 4, skip the space. So we're looking here for the word greater. Yep, I++, that's all good. Start is set to 4, I is set to 12. That substring should give us greater. There it is. It's got a leading space on it, which... how do I want to cope with that? So the leading space is only a problem in the sense that if there are multiple spaces on it, so yeah, no, I'll need to trim it. I need to trim it because I need the total length of the thing we matched, including the leading white space, to advance the scan index by the correct amount. Alright, so that's fine. So there we go. So that works. So Lexeme is now greater, so that we need to add... we gotta track two things here. We gotta track the one we use for the lookup, and we gotta track the one that we use for the instruction increment. So I'm gonna do that inside the keyword match method, I think. All right. So I think that actually simplifies this. Keyword equals that. I think I can just do that. And then in keywords.match, public static string normalize spacing what do I want to split on? Any kind of white space. So one of those tabs. I guess carriage returns. New line. String split options dot remove entry. Right, literal space, literal tab, literal new line, literal one of those, string split options dot remove entry entries. What's that complaining about? Okay, so that is going to take string input, string expected, and cool. All right, let's throw in a couple more there. Sweet. Okay.
In April 1955, the Ministry announced that the results of a 5-year investigation into flying saucers by the Royal Air Force had been submitted to high-ranking officers, but it was never to be revealed to the public for security reasons.
Okay, so that's going to normalize those. Will the Rockstar website have an AI feature that will sing your code? I have an opinion about artificial intelligence. I think they should stop making it do things that are fun. Singing is awesome. The idea that somebody out there is like, yeah, you still have to do your taxes, but we've made an AI that can sing songs. I'm like, no, go away. Get back to me when you have an AI that can do my taxes, and I will sing my own songs. Thank you very much. So no, it will not. There will be no AI on the Rockstar website. None whatsoever. I have opinions. Also, we've been 5 years away from general AI since, I think about 1958. So, yeah, it's a hype bubble. If you have money in it, you probably want to give it about another 6 months and then get all your money out before the whole thing crashes down spectacularly. Right, we are here. Oh, right. Feels like all the guest lectures incorporate the how can we use AI on this problem at my university. I mean, yeah, let them have their fun. It does burning a ridiculous amount of power, and we can constify that. All right. All right, so we got X. That's cool. We got is. We got greater. Keyword plus equals lexeme. Keyword is now is greater. Keywords.match. Token types 1 greater than partial. Yes. Look ahead from plus equals that. Continue. Ooh, interesting. Lexeme is now Han. Why? There you go. One of my little monitor people. Han and Chewie, but we don't want Han, we want Van. Where we got Van? It chopped the T. Why did it chop the T? It chopped the T because look ahead from is in the wrong place. Why is look ahead from in the wrong place? Or rather, how did we end up with is greater Han? Ah, no, I know why it's happened. See ya, Randy Bob Andy. Take it easy. Catch you for the next one.
I am convinced these objects do exist. They are not manufactured by any nation on Earth. I can therefore see no alternative to believing the theory that they come from some extraterrestrial source.
Okay, so I think is greater Han. Let's figure out why that's happening. Right. Lexeme is greater. Yes. Keyword plus equals Lexeme. I'm jumping ahead too far. Because we've already incremented that by 1, so... Yeah, it's a great song, this one. It's Gary Moore during that very, very brief bit of his career when he wasn't in Thin Lizzy anymore and he hadn't turned into a blues guitar player. And he was a phenomenally good blues player. But this kind of stuff, I love this. This music is my life. Lexeme Han. Why Han? You know what? I don't know who wrote it, actually. Okay, that's properly weird. Ah. Knopfler is an absolute legend. He's the guitar... Like, Dire Straits was the band that got me into music. My dad loved them, still does, and He was sort of got me listening to Brothers in Arms and Tunnel of Love and all that kind of stuff. Phenomenal guitar player. Right. Okay, that's interesting. I think I'm missing a bailout clause here. I think it's doing the right thing, but then it's finding it, but it doesn't know what to do when it's found it. Hello, Mr. Unchosen. Is including the length of X before is. Also, hi. Hello, welcome to the stream. Let's see if we can figure out why this thing is blowing up. Right. So, X. Yes, that's fine. Token types count as 1. Current plus equals... Ah. Yep, okay. So return scan identifier. Alright, so that's picked up that one. Yield return token. Token is an identifier token with a lexeme of X at line 1. That's correct. Okay, scan token. What do we got? Next. What is next? It's a space. Fine. C equals I. So this is the I on is. So this is going to go into scan identifier. Yep. Return scan identifier. Okay, so we are looking at lexeme is. That's good. Look ahead from is 2. Keyword is. Token types, yep, that's good. Right, what do we got? Look ahead from here is set to 2. Lexeme is. Lexeme.length is 2, so that's fine. Increment that. Right, so now, look ahead from starts at 4. So we step into here, we start at 4, we consume the leading white space. We pull all that content out, so this is pulling out the is greater, yep. Lexeme is greater, correct. Keyword plus equals lexeme. Keyword is now is space greater. Token types returns 1 partial match, that is correct. Look ahead from is currently 4. Lexeme.length is, yeah. Okay. Look ahead from is 12. Step into that method. Source here is X is greater than... Give me a visualizer on that. Okay, boom. So there we go. So what do we actually got on here? Can I drop that in somewhere? Does that want to live anywhere in this? There we go. So, look ahead, start at 0, start at 1, start at 2, start at 3, start at 4, 5, 6, 7, 8, 9, 10, 11, 12 is the correct position. Yep. Lexeme is now than with a space on the beginning. Keyword plus equals lexeme. Keyword is greater than. Token types has one complete match. Okay, so far so good. Current equals that. That's going to give us back a token. Token is a greater than token at line 0, line 1, that's correct. Yield return that. Okay, so far so good. Scan token. Whitespace. Scan token. Scan token. What do we got? We got Y. Scan identifier. Yeah, that's cool. Lexeme here should just be Y. Yeah. Yep. 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 No. We have missed a very, very important distinction. So that's doing a keyword match. And it's matching true. So the keyword matching code in here, if it's doing a prefix match, it has to append a space. Otherwise, if we give it Y, it says, well, Y could be the first part of yes, and yes is an alias for true. Yeah, of course. So keyword equals keyword that starts with Yep. So if there's an actual match, otherwise, yeah, we need to drop a thing in here. Actually, I'm going to explicitly stick a... Right. So now all that's failing here is X is Y. Let's even figure out why that one's not working. All right, so what do we got? We got Lexeme is X. Lexeme is. Yep. Okay, here we go. So this is the fun part. So this is where we get into the X is Y versus X is greater. So at this point, we got the whole, that ain't gonna match anything. Cool, all right. So token types now is 0. So if at any point in the look ahead we find a definite match, we need to capture it, is what we need to do. So keyword plus equals lexeme, and so if we find an exact match, I don't need dinner. I have Pingvin, Norwegian salted licorice pastils. They are delicious and sugary. They have caffeine in them. They contain 8% ammonium chloride by weight, and basically if you eat one of these every 3 or 4 minutes, you can keep going forever. I'm going to get this working. I'm going to get the look-ahead scanner working, then I'm going to wrap it up. That's going to be today's progress on the Rockstar. And we're nearly there. I know why this isn't working. It's not working because if it finds something and then it looks ahead and it doesn't find anything, it needs to fall back and give back the one that it was going to. So keyword equals that, token types equals keywords dot match, and at that point we want to say if token types dot any hang on to this in case we want to return it. So I find that the really salty licorice is a really good self-regulating snack, because the process of eating it is pleasurable in a way that has very little to do with how it tastes. And so it sort of ticks the box that stops you getting snackish without, like, if I had chocolate on the desk, it would be gone. Anything. If I had carrots on the desk, they would be gone. Tomatoes, popcorn, anything like that. Just, with this, you kind of slow down because it's not that delicious. Right. So what do I need in here is... Yeah. Okay, so token type match. I need to put a default in here. Yeah. So token type match. So if any of those equals that, match equals token types dot first one of those. Nicely put, Cinciad. It is. I like it enough not to seek anything else, but I don't like it so much that I eat it all at once. That is exactly how it works. Okay, so if we don't match anything, at that point, if the match is not equal to the default, see ya, Sander. Nearly there. Right. All right. Span at it again. Undo all the things. I'm in the zone. I gotta get this piece working. Okay, there we go. Cool. That's almost working. Almost working. Okay. So put that in there. If that matches nothing, and then return token. All right, this is good. This is really good. We have, I mean, it's really good apart from the fact it doesn't work, but you know. Right, let's debug something. Take it easy, Jake. Right, what do we got? X is Y. Okay, this one should work. So... Lexeme is, yes. Stash the match. There we go. I wonder if I can actually capture the token there. Token type, source start and current. No. Yep, look ahead. That's fine. Okay. Lexeme now is Y. Token types equals nothing. So now we're going to say, alright, match, we have one. Current, so keyword dot, okay, that's interesting. Keyword is now is Y. Ah! Computers are stupid. Green, 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 green. All the things. Everything is green. And excellent. Look at that. All right. Wow. All right. Commit quickly. Right. No, I think we can make this simpler. Mm-hmm. All right. I don't like the way that match method works. Hello, Xcoding. You catch us just at the end. I'm just cleaning up a couple of things and then gonna call it a night. I think this would be better off as a Okay, so what I want to do here is maybe split this. I think this would be much easier to work with. What's your thoughts on Vim, Dylan? I know it well enough to get X Windows working again after I've broken it so bad I can't load up something like VS Code, but it's not my jam. Vim for me is a little bit like Git. On a good day I can do some quite impressive stuff with it. On a bad day, about every 30 minutes, I stop, throw it away, go back to the beginning and start again. Alright. I hate that.
Like a time bomb, bound to explode. Sometime in the future, depends on how heavy the load. But don't worry, it's not gonna blow for a while. Maybe when our decision is reached at the end of my eternal track.
It really bothers me that you can't do a useful first or default on dictionaries. Okay, let's get the... Our dictionary's ordered in C#. No, they're not. They're implemented as hashes, so... With you in a second, folks. Right, nearly there. Come on, we can get this done. So, string text, and this one... This streamer doesn't have a raid message. No, I'm not cool enough to have a raid message. I don't know what raiding is. I do know what raiding is. I don't know how one does it. Yay! So I don't spend a huge amount of time participating in Twitch as a consumer, you know? So I'm aware that there are all these cool things folks can do with it, but I have very few of them set up. There we go. Okay, almost there. So we got a try perfect match, is nice. And now what I got in here is partial matches. So this needs to pull in the whole... that one there. return keywords where that keyword dot okay, keywords where pair.value.any keyword starts with text equals that. Yep. Actually, no, we'll to array that. No, that'll do. All right. So that's back over here. So one thing to be aware of, Stony, is I'm running this through Restream because about half the folks watching are watching on YouTube, which means I don't have the Twitch user interface open, which may well be a mistake. I should probably fix that, shouldn't I? Anyway, we can worry about rating later. Right now we got stuff to fix. Okay, almost there. Okay, right. This was working. Now it's not working. Why is it now not working? Which tests are failing and why are they failing? Okay, so it's just the... is greater than type things are failing because they're not picking up the correct number of tokens. Yes, you're right. I can't use Twitch command. So, Cincietta's So I just noticed this is a secret gist, but the secret gist is in the chat, so I'm assuming you don't mind us taking a look at it. What language is this? Kotlin. That's nice. That is significantly nicer than what we've ended up with. Anyway. Right. What have I messed up here? This was working. And now it's not working. And what did I do wrong? Right, I'm gonna roll back all of the actual scanner code here. Okay, so this was working before I went and messed around with the way the matching is working. Okay. So that's the bit we don't need. All right, let's figure out why. Programming question. Why do you occasionally go back to when the code was working? Because I've missed a step in the course of changing something that worked and was ugly to something that is pretty but does not work. And so I like to backtrack to a point where I knew it was actually working properly. And normally if I get from a point where I have working code and then I have code that doesn't work, it means I try to do too many things in one go. Alright, what do we got here? We got keyword lexeme is X, yep, that's fine. Return identifier, okay, so far so good. Yep. Okay, so now look ahead should be is. Yes. Yep. Yep. Yep, okay, so we got some partial matches. So yeah, it's kind of like, let's go back to where we wanted to start from, but now we've learned a way of it not working. Okay, so look ahead from's that, implement that. So now lexeme is going to be greater. Yep. Yes, we got a partial match, that's cool. Match is still equal sign. Yep, look ahead, continue. is greater than, so keyword plus lexeme. Okay, so now we've got a perfect match and nothing. Current is keyword length plus 1. I think that needs to... So what have I just matched? I've matched is greater than. So that's given me a concrete match, which is cool. So I need to... Okay, so that's going to give back the wrong thing. Because it's not consuming enough. Yeah. Okay, so let me stop that. So those are consuming there. They're returning too many things. So current is keyword.length plus lexeme.length minus 1. Okay, that's fixed almost all of them. Except for this case here, which is X is Y. Alright, so this is now the problem where if we hit the edge case, okay, so boom, that's our lexeme is... Right. Lexeme is X, yes, cool, right. Skip it again, what do we got? Keyword equals that. Lexeme is, yes, skip forward, okay. Partial matches is... So we've got a potential match and we've got a perfect match. Yep. Yep, look ahead from that. There we go. Okay, so now lexeme is Y. Try perfect match should return false. Okay, that's good. Token types there is 0. Okay. So that shouldn't be advancing by that much. So if I switch that over, now the other 3 break. That needs to come down. I think. Should be 4 but was 5. Right, what I'm trying to figure out, there is a logical difference between the code I had previously and the code I got now. And I can't work out what that is. There's some nuance about the exact scenario in which we decide what to return. So, keywords.match here. Okay. Yeah. Right, back it up, back it up, back it up. I just can't quite figure out what the tiny little detail here is.
It's almost there. It's just one tiny little detail. So the specific scenario is that when we got x is y, apparently YouTube has disappeared. Let me see what YouTube's complaining about. My YouTube says it's live now. All right, well, we're going to turn the music off for the rest of the stream. Apparently that's on. Your stream was interrupted. Ah, yeah. Copyright. Fun. Yeah.
All right. Yep, that's all fine. So that's xseam. Yeah, that's fine. Return the identifier. That's fine. Yep. So now we're going to scan is. Yep. We've got a perfect match. We also have candidate matches. All right. So now, while true, lexeme equals look ahead that. Partial matches is nothing. I think I just need an else clause in there. There, boom, got it. All right, that's a wrap, folks. We'll be back later, probably later this week. But fun and games. I didn't think that was going to take 6 hours to plug in, but there we go. Thank you for watching, fam. That was great fun. You folks will take it easy and have fun, and I'll figure out a nice way around YouTube's not allowing the music stuff on here. But we'll figure something out. All right. Take it easy, folks.